3.1 Graphing Equations, Plot Ordered Pairs. The rectangular coordinate system, so we know what the coordinate plane is. So that's like the actual name of that is the rectangular coordinate system. So we have ordered pairs, two numbers associated with a point on the graph. The first number gives the horizontal location of the point. The second gives the vertical location of the point, also known as just x and y, right? So for x, don't we go left and right? And for y, we go up and down. So a coordinate is a number in an ordered pair. So you have the x coordinate and y coordinate. Your x-axis is the horizontal number line. So our x-axis is this one, the horizontal number line. And then the y-axis is the vertical number line. So this one right here. Everything is labeled as well on the graph. Your origin is the point of the intersections of the two axes. So we know the origin, it's right at the center. And then quadrants, there's 4 quadrants, it goes counterclockwise. So we have 1, 2, 3, 4. But all of that is labeled, and we know how to plot points. So that's what we're going to do. We're going to practice plotting points, and then we're going to state which quadrant it's in. So because I know most of us are pretty comfortable with plotting points, I want you to please pause the video, plot the point, and then say what quadrant it's in. Alright, so for A, we have 4, 2. So for A, we're going to go right 4, up 2, because it's positive. Right and up is positive. And that's in quadrant 1. So we say Q1. For B, it's negative 3, negative 2. So negative, I go left 3, and negative, I go down 2. So negative 3, 2. So that's B and A. And that is quadrant 1, 2, 3. So remember, counterclockwise. So that's in quadrant 3. C, so we go right 2, down 3. That's quadrant 4. Now we have D, which is 0, 4. So I'm not going left and right at all because x is 0. So I'm only going to go up 4. Now that's not in a quadrant. It's on an axis. So that is on the y-axis. And then our last one is 5, 0. So we go right 5. And we don't go up and down at all because y is 0. So, and that is our E point. Now that is not in a quadrant. Since that's not in a quadrant, we can see it, it's actually on the axis itself, and that is on the x-axis. Alright, we're going to determine whether an ordered pair is a solution. An ordered pair, or a point on a graph, is the or a solution to the equation. So when we graph something, it's the point to the, or it's the solution to the equation. So say, I'm just going to use this as a graph just to show you an example. So say I had this graph, right, and I had an equation that represented it. Any point on this graph, any point that is on this graph is the solution to whatever the equation is. Meaning if you plug in x, it will equal y when you work it out. That's why we use lines and graphs, because it's impossible to write all of these answers. So we draw the answer so we can get all the answers in a nice uniformed picture. So to determine whether a point, so 4, negative 2, is a solution to an equation, we're going to plug it in. So we're going to plug our point into 2 times the square root of x plus 5y squared equals negative 4. This is our x, this is our y. The best habit that you can get into is to always label your points. A lot of the times in higher level math, it's just knowing how to use formulas. So labeling your points, it really does take a lot of room of error out. It really does, I promise you. So label your points, take the time it takes. It doesn't take much time. Label your points. So let's go ahead and plug it in. We have 2 times the square root of x, and x is 4. Anytime I have to plug in a variable, I always wrap it in parentheses. That pays off later through your math classes. And that's plus 5y squared, and the y we're plugging in is negative 2. And that equals negative 4. Alright, so let's simplify. We have 2 times the square root of 4. So the square root of 4 is 2. Then we're going to add that to 5 times, so negative 2 squared is 4, PEMDAS, and that equals negative 4. So let's keep simplifying. We have 2 times 2 is 4. 4 plus 5 times 4 is 20, equals negative 4. Combine like terms, we get 24 equals negative 4. That is not true. Since it is not true, this is not a point on the graph. So I would just say no, that is not a point on the graph. So if I were to graph this equation, which later on in college algebra and stuff like that, you will learn to graph stuff like this, that this point would not be on the graph of the equation. Graphing linear equations. A linear equation in 2 variables is an equation that can be written in the form ax plus by equals c. That is also known as standard form. We'll talk a lot more about that through chapter 3. So that's standard form. A, B, and C are real numbers. A and B cannot be 0, and it's standard form. I know I have it written, but I like you to write it as well because it kind of sticks better in your head. Alright, there are a few ways that we can graph a line, and you can use any way you want, but I'll tell you what I suggest you use. So you can use a t-chart or an x and y chart. We will practice that. You can use slope-intercept form, so which is y equals mx plus b. This is the form I prefer you to use because it's the form that's going to pay off later on. But that's completely up to you. But if you are going to college algebra, pre-calc, and trig, you should be using form 2, I guess. Method 2. So our m, that's your slope, and that stands for our rise over run. So our rise over run, we can either go, if we have a positive over a positive slope, we go up and right, and that's a positive slope. So that's what it looks like. Right here, that's what it looks like. If you have a negative over a negative, that's down and left, because what's negative over negative? That's positive. So that's why it's still a positive slope. Do you notice for positive slopes, you can go up and right, or you can go down and left? It's up to you. I like to go both ways. We have other slopes. If you have a positive slope on top and a negative slope on the bottom, you go up and left. That's a negative slope. If you have a negative slope on top or a positive slope on the bottom, or a positive value on the bottom, you go down and right, and it's also a negative slope. So you notice for negative slopes, you can go either way. You can go up and left or down and right. So it doesn't matter. It's up to you and what you want to do. If you have a negative slope, go up and left. If you have or down and right. If you have a positive slope, you can go up and right or down and left. Your y-intercept, that stands for b. I like to say that's the start, also known as the initial value. I'm throwing that at you now. You don't need to know that, but I'm throwing it at you now. So if you take me for college algebra, I'll know you know that. It's okay if you forget. So the y-intercept, that's what we call the start. It's called your initial value. Now, why do we call it the start? Because you always plot the y-intercept first. The point is always 0 and whatever the number is for b. Then you use the slope to create other points. So you plot the y-intercept and then you do up and right or down and left or whatever your slope is. The last way that we can graph is to use x and y-intercepts. So to find your x-intercept, which is also called a 0 and is also called a root, you're going to make y equals 0 in the equation and solve. The point will be number 0. So just like we always find intercepts. And to find the y-intercept, you make x equals 0 in the equation and solve, and the point will be 0 number. Whatever intercept you want to find, you make the opposite variable 0 and solve. So if you're trying to find the x-intercept, the opposite of x is y. So you make y 0 and vice versa. Alright, we are going to practice using intercepts and our t-chart. So for our first one, we're going to practice using a t-chart. So a t-chart or an x and y chart, it's this. I use that a lot. If you continue to take me through your math classes, you're going to see I really bust out a t-chart because it's very applicable. So it doesn't matter what number you pick. We'll explain that more through this semester, especially in this chapter. Y lines, I can pick any x. So what do I pick? I usually pick -1, 0, and 1. Now, why 3 points? Because a lot of the times you probably grew up saying, oh, 2 points is okay. But we do 3 points for a particular reason. It gives us a shape of the graph. If we practice it now with lines, we'll always remember I need 3 or more points to get me the shape of the graph. We want to see how it's going to look from left to right, right to left. We want to see the shape of the graph. That's why we use 3 points. So let's go ahead and plug it in because we have x, let's find y, so we plug it in. So we have 2 times x, which is -1, minus y equals 3. So 2 times -1 is -2, minus y equals 3. So I'm going to add 2 to both sides, and we're left with -y equals 5. Now, we're not allowed to have -y. That's because it's not by itself. So we're going to multiply by -1. All that does is it changes the signs. So -y becomes +y, +5 becomes -5. And that's our point. So -1, -5. And we can plot that right now. So starting at the origin, so starting at 0, 0, I'm going to go left 1, down 5. And there we go. Now, I want you to go ahead and pause it and do 0 and 1. Alright, so let's go ahead and plug it in together. So we have 2 times 0 minus y equals 3. So 2 times 0 is 0, so we don't need that anymore. We have -y equals 3. Now, we're not allowed to have -y, so we multiply by -1. And all that does was switches the sign. So -y becomes +y, +3 becomes -3. So our point is 0, -3. Now we can plot that. So starting at the origin, I don't go left and right, I just go down 3. Alright, our last point is 1, so let's go ahead and plug it in. We have 2 times x, which this case is 1, minus y equals 3. So 2 times 1 is 2, minus y equals 3. I'm going to subtract 2 to both sides. And when we do, we have -y equals 1. You know we're not allowed to have -y, so we get rid of it. And we have y equals -1. So our point would be 1, -1. We can plot that, so we go right 1, down 1. And now that we have 3 points, we can go ahead and connect the dots. So with my ruler, I'm going to connect the dots. And then go ahead and draw my arrows, because lines go on forever. Unless stated otherwise, but that doesn't come up. Okay, so we did it practiced using a T-chart. Now you can use this. If you forget how to graph a line, or if you forget how to graph something, bust out a T-chart. Alright, so for B, we're going to use X and Y-intercepts to find our graph. So our first one, we have X-intercept. Now what's the opposite of X? It's Y. So we're going to make Y equals 0 in the equation. So we have 4x plus 3y, and y this case is 0, equals -6. So we have 4x, 3 times 0 is 0, so we can just get rid of it, equals -6. Divide by 4. So we have x equals -6 over 4, which we can simplify by dividing by 2. And that's -3 over 2. Now, -3 over 2 on a graph makes no sense to me, so I'm going to switch this to a decimal, and that's -1.5. When you graph, use decimals. It's much easier. Convert your fractions to decimals. So our point is -1.50. So let's go ahead and graph that. So I'm going to go left, -1.5. I don't go up and down at all, so that's about 1.5. Do you notice I say about 1.5? Because every single graph you draw, it's all a sketch, because you can't draw a perfect graph by hand. So that's why it's all a sketch. So you do best where you think it's going to go. Best possible thing that you can, or best possible place you can put it. Alright, now we have our y-intercept. So I want you to go ahead and pause this and find that y-intercept. Okay, so for y-intercept, the opposite of y is x, so we make x equals 0. So in our equation, we have 4, wrong color, we have 4 times x, which is 0, plus 3y equals negative 6. So 4 times 0 is 0. We can get rid of it. We have 3y equals negative 6. Divide by 3. So we get y equals negative 2. That means our point is 0, negative 2. So I don't go left and down at all, or left and right at all. I just go down 2. And then we connect the dots. Now, I'm not the biggest fan of using intercepts to graph, but if all else fails, do it. You'll still get the answer. It's just another way to do it. Alright, we'll practice using slope-intercept form in a different chapter. So in a different section, we're going to practice a lot more graphing in 3.3. This is just like that introduction to graphing. So in 3.3, we will graph a lot more. Okay. Alright, graphing non-linear equations. So this is what a parabola looks like. It's x squared. Parabolas, or x squareds, those are called quadratics. So quadratic equations have a power of 2, meaning the highest exponent is 2 and nothing greater. And this is what a quadratic looks like. It's a parabola, it's a happy face, or a sad face. We'll talk more about that through the semester. There's absolute value, so an absolute value is a v. And the square root, it's like a little thing coming out of the origin. Alright, example 7. For income tax purposes, Ron uses a method called straight line depreciation to show loss in value in values of a copy machine he purchased for the department. Ron assumes that they can use the machine for 8 years. The graph shows the value of the machine over the years. What loss in value occurred during the first year? So we're talking about the first year. So the first year, so if we broke this down into years, that's first year, second year, third year, fourth year, fifth year, sixth year, 7, 8 year. Now I knew that because there were 8 tick marks, so it was going by 1. And now for the 12s, there's 12 tick marks, so I know it's going by 1 again. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So X represents years. It tells me that right here, because that's the x-axis. And then Y represents value, which is money. And it tells me right here. And it's in thousands. It's in thousands. So if I wanted to write 1,000, it would be 1,000, because it's spelled. So that's why we do it that way. So we want to know the loss the first year. So that point right there. That point, it's not perfectly somewhere. I don't know where that point is. But I do see this perfect point and this perfect point. So the first perfect point is 0, 11. And the second perfect point is 2, 10,000. Or just 2 10,000. Sorry, that's supposed to be 11,000 because we're talking about thousands of dollars. There we go. So then if we can find the change between 0 and 2 years, we can find the change of 1 year. So 2 years, get different color. So 2 years, the change, it was 11,000, and then it went to 10,000. So technically, didn't they lose $1,000? They did, because it went down $1,000. So that's in 2 years. So that means in 1 year, if it's 1,000 in 2 years, 1 year is minus 500. So the loss in value during the first year is $500. And the reason why we write it in words is because it's asked in words.